So guys, now let us take an example. Let the router fetches an IP address from the IP header of the incoming packet, and let the IP address is 128.2.3.5, and our objective is to look up into this mtry data structure in order to find the route as per the longest prefix match principle. So the very first thing that we need to do is to convert the given IP address into its equivalent binary form. So this is the binary form of this IP address, which is a 32-bit address. Now we will parse this 32-bit IP address into this mtry data structure starting from the root. Now note that route lookup algorithm uses an intermediate data structure called stack. We start our search in this mtry data structure from the root as usual. Alright, since we are starting our search from the root, in the stack we always push the don't care child of the current node. At this point of time, the current node is the root where we are starting our search from, and the don't care child of the root node is the node number 4. So in the stack we push the node number 4, and we also push the second thing in the stack, and that second thing is the number of bits of the input string which has been parsed so far while we are traversing this mtry data structure from top to bottom. At this point of time, we are at the root node, therefore the number of bits of the input string that we have parsed so far is 0. Alright, that is, we are on the first bit. So these are the two things which we need to push as a single entity in the stack: the don't care child and the number of bits of the input string which we have parsed so far while we are traversing this mtry data structure from top to down. So now let us begin our search in this mtry data structure. The first node of the input string is 1. So we will take the path along the 1th child of the root node, and we land at the node number 3. The prefix length of the node number 3 is 8, so we will going to match first 8 bits of our input string with the first 8 bits of the node 3. Alright, and they exactly matches. Now as the second step, we also need to push the don't care child of the node 3, but in this case the don't care child of the node 3 do not exist, it is null. So no need to push anything into the stack. Alright, and we will continue our search down the tree. So the next bit of the input string is 0, so we will take the path along the 0th child of the node 3, and we will land at node number 7. The prefix length of the node number 7 is 8, so we will going to match the next 8 bits of the input string with the 8 bits of the node 7, and they exactly matches. Because they exactly matches, therefore we will going to push the don't care child of the node 7 into the stack. So don't care child of the node 7 is 6, that is 6th node, and by the time we reach the node number 7, the total number of bits that we have parsed on the input string is 8 plus 8, which is 16. So 16 bits of the input string has been successfully parsed so far. And after making an entry into the stack, we will continue our search. Now the next bit of the input string is 0. So we will take the path along the 0th child of the node 7, and we land at the node number 5. The prefix length of the node number 5 is 16, so we will going to match the 16 bits of the input string with the 16 bits of the effective prefix of the node 5, and they do not matches, unfortunately. So the moment there is a mismatch, using this stack we will going to backtrack. So we will backtrack and we will shift our search from the node 5 to the node 6. But how? We will going to pop the element from the top of the stack. So when you pop the element from the top of the stack, it essentially says that we need to begin our search from the node 6, that is this node, and we have successfully parsed 16 bits of our input string. So it essentially says that we need to shift our search to the node number 6 and 16 bits of the input string has successfully passed. So we need to begin matching the bits of the input string from this particular bit, because previous 16 bits have already been passed in the mtry data structure. All right. So what we will going to do, we will going to shift our search to the node number 6 because we have popped out this entry from the stack. The entry of the stack essentially tells us that where we have to shift our search in this mtry data structure. So here, after shifting to the node number 6, the prefix length of the node number 6 is 16. So we have to match the 16 bits of the input string with the 16 bits of the node 6, and they matches. All right. So here the entire input string of the input is exhausted. So this is the node where our search ends. So the node 6 corresponds to the route 128.2.0.0/16. So this is the route which matches with our IP address as per the longest prefix match principle. And the next hope of this route, that is the data part of the route, will be used for forwarding the traffic. And note that when your route lookup algorithm ends, it is not necessary that your stack should be empty. All right. Your stack may have some elements by the time you have found the route of your interest. So you have to discard or destroy the stack which may contain some elements in it the moment you found the route of your interest. All right. So in the stack, we always push the node which is a don't care child of its parent. Whenever there is a no match, backtrack using stack pop operation. Destroy the stack after the search is complete. All right. So we will destroy the stack because we have already found the route of our interest. Let us discuss the route lookup algorithm with one more example in the next lecture video.